Hey everyone, as previously we discussed about photodiodes. So this concept was completed at the last class. Now we go for next topic, that is nothing but Schottky diodes. Here the Schottky diode was invented by Walter H. Schottky. That's why it is called as Schottky diode, and it is also called as Schottky barrier diode, and also it is called as hot carrier diode. So why it is called as hot carrier diode, so we'll discuss later. And so it is nothing but it is a semiconductor diode, and formed by the junction semiconductor with a material. Okay, so it is a semiconductor diode, so with help of materials. So here this is the diode and with help of material. And so this is the symbol of Schottky diode. So this is the symbol of Schottky. And so anode, cathode, so this is the symbol of Schottky diode. And so how the structure was forming by Schottky diode, so this is the structure of Schottky diode. And one thing here, remember that as compared to normal semiconductor diode and Schottky semiconductor diode, here the Schottky semiconductor diode having only n-type n-type material with help of metal, so metal diode. So here the metal used as a gold, so gold metal. And so generally the it is look like this. So here this is the shape of a Schottky diode. So generally it looks like this. And so here normally semiconductor has having a p-type and n-type, but it has only n side, so n-type only. So it has electrons or majority charged carriers, and metals also having full of free electrons. So here metals having electrons and n-type material having electrons. Here the majority charged carriers are electrons. Why? Because metal having electrons and type material having electrons. So that's why the majority charged carriers are electron. It has the metal semiconductor interface. So here this is the metal semiconductor interface, which means that so suppose this is nothing but diode. The metal was framed like this. So this is the metal. So metal was conducted here. So here the metal colored used as a gold, so gold metal. So it is a unipolar device, we already know that. So it doesn't have a p side. It is a unipolar device, it is a only one pole, it do not having p side. So, and one more thing, remember that here there is a no depletion region. So here why depletion region was not there? So suppose the electrons was moving this side, so um, there is a no depletion region. So remember that it can be used as a high frequencies. It works as on and off switches. So it works on high frequency ranges. In that condition, it act as a on and off switching functioning. So it is a very fast switching functioning was there. So it was then greater than 300 megahertz frequency range. And so it is a ratification of high frequency signals. What do you mean by ratification, which means that AC signal was converted into DC signal. So the normal ratification was like this way. So suppose I'm taking as a simple circuit here. So I'm applying low frequency. If I am applying high frequency at the low frequency ranges, um, here that this is nothing but positive and this is nothing but negative, and negative side was clipping was occurred. So and so if I am occurring high frequency range, so here the small noise was produced by here. So as we observed in the Schottky ratification, so Schottky ratification at that high frequency range, there will be noise very less, noise will be not absorbed here. So as normal PN junction diode having noise at that high frequency ranges, but at that Schottky level, Schottky diode, it doesn't have any noise was occurred. So we can observe that it is a low forward voltage drop and a very fast switching action. as we compare vi characteristics, which means that voltage current characteristics. So generally we observe that pn junction diode, so as the forward bias as well as reverse bias, forward bias was starts like this. So if 0.7 at that silicon, 0.3 at that germanium, and so as reverse bias certain voltage was applied at that doping will be started, so which means that breakdown, reverse bias breakdown, and so this is nothing but new voltage, we already know that. So as we compared with p-n junction diode, so here the silicon material was started with 0.7 and germanium material was started with 0.3, but in that short key it starts with 0.2 or to 0.25 voltage. So the raising will be started like this, and so here as reverse bias also there is the reverse breakdown will be occurred very fastly as we compare this vi characteristics. And the applications of Schottky diode is it can be used as a voltage clipping and clamping circuit. So we mostly observe this clipping and clamping. The meaning of clipping and clamping, which means that here the negative side, as we observed here graphs, the negative part is clipped, means that cutted, clipping. So we discuss in that further subjects as in detail what you mean by clipping clamping. So here the clipping means it doesn't appear clear, and so it rectifies high frequency signals, and so it acts as a switching device. So that is the applications of Schottky diode. Students, if you having any doubts ask me freely, and so notes కూడా కంప్లీట్ చేయండి, మన డౌట్స్ ఉంటే అడగండి. థ్యాంక్ యూ.